Hi students. In this video we're going to talk a little bit about how the data can be spread out away from different measures of center. In Module 6 we'll see how the data can be spread out around the median, and in Module 7, which is going to be our next video, we'll see how it's spread out around the mean. Remember, each one of those had a different representation, both pros and cons. And it's good to remember that at times one was better than the other, or perhaps more useful than the other. So when we're talking about measures of spread about the median, we often refer to the quartiles, or we cut the data up. And again, the median was already cutting the data in half. If we take the top and the bottom half and then cut those in half, we'll have 4 chunks of data, 4 quarters. And that's what we would call quartiles. Let's jump over to the web apps. This is an example from a different set of data involving reaction time, whether someone is on their cell phone or not. All right, so just taking a look at the data, we can see there's 32 data values in each group. They have different mean values, but again, in this module, we're talking about the median. So we can see that there's a difference in the median. The no cell phone has a lower median, which means that reaction time for most of that group, half or more, was less than the reaction time for those who were on their cell phone. And so what you can see is you'll see a lower boundary, which is the minimum value, then what's called Q1. Again, that's just the line in the sand that says, here's my first quartile value. But really, if you think about the 4 chunks of data here in the yellow kind of box plot, there's a chunk at the bottom, which has kind of a tail. There's a chunk in the middle here, which is the left-hand side of the box. There's a chunk above, which is the right-hand side of the box. And then there's a chunk above. Those are the 4 chunks. And each one of those chunks represents about 25% of the data. So what I can look at and I can see is it does look like, and I do see an outlier here with the second set of data. And so that outlier is kind of letting me know that there's at least one person who is way bad with reaction time when they're on their cell phone. So we want to not have maybe not have them driving ever with their cell phone. That would be extremely safe. So what can we interpret from this? We have the lower quartile Q1 and Q3, and those are kind of the lines in the sand, if you will. And then the distance between those two is known as the inner quartile range. And that's the IQR. So that's what's located right up here. Now, if you take that inner quartile range and multiply it by 1.5, what you're doing is creating kind of a wider range value. And we take that and we add it to Q3. That means we add it on at the top end, and we subtract it from the low end. And when we add it to the top end, we kind of create this almost a boundary, if you will, a fence. And any value outside of that fence is what we tend to say is an outlier. Now, depending on your future in statistics, other classes might have extreme outliers, which would be more than 2 times that inner quartile range, above the upper quartile. So again, all we're doing when we're creating these quartiles and these boundaries is helping us to visualize how spread out things are. So in this set of data, I can kind of tell, yeah, I can see that the median in the yellow top one is actually lower than the Q1 for the green or the cell phone data. So that means 50% of the people who don't use their cell phone are actually having lower reaction times than 75% of those who are on their cell phones. So if you picture that, we can kind of see a little bit about how the data are connected. And we can also then kind of see a little bit about how spread out they are. You can go through a few other data sets as well, depending on what you're interested in. So this is Airbnb price by the type of room. And so as you can imagine, the price in New York City of an entire apartment is going to be much higher than the price of private rooms or even shared rooms. And if you take a look at this data, you're actually able to see that the low end, the shared room, is actually fairly compact, if you will. So the spread is not, really out there. And there are a lot of outliers. A lot of outliers in all of the data sets when you look at this. But the main set of data, the main chunk of data, if you will, is really pretty compact compared to the kind of the range of values you could see if someone is trying to rent their entire apartment. And so again, this box plot gives us the visual evidence to say, hey, even though they seem to start about the same place, maybe they're not really all that closely related. The entire apartment is extremely widely spread out compared to a lot of the others. Now that doesn't mean we don't see some data values. As you can see, there's a lot of data values for a private room that might be higher than an entire apartment range values. But again, that's all of the anomalies that we see when we're looking at these. Now the box plot's really good for this. If you chose, you could actually represent these with a histogram, and that can help as well to kind of give you that same feel. But a lot of times what you'll see with data is that because the histogram requires additional pieces and oftentimes different scales, it becomes more challenging to see how they're actually linked together. So you can see the scale on the green one goes up to 200. The scale down here goes up to 1,000. The scale down here goes up to 1,000. So again, it looks like there's a, in terms of the number, it really seems there, but that's because there's just not as many shared rooms, only about 1,000, compared with the other private rooms in the entire apartment, which have about 13 to 14,000 each. So again, pretty good idea to kind of get a feel for how these are, and that side-by-side box plot could still tell you. I mean, take a look here. Private rooms, I can see that third quartile, or Q3, is lower than Q1. So that means if you're just trying to find a private room, 75% of all of the private rooms are priced lower than 75% of the entire apartment pieces. So, in any case, I think this gives a pretty good idea of the interquartile range along with the median. So remember, when you're calculating, you start with your min and your max, but once you create the quartiles, the Q1, Q3, that all stem from the median, then you can start saying, well, if I took my inner quartile range, in this case for shared room it'd be 40. If I take 40 and I multiply that by 1.5, that gives me 60. So add 60 to the top end of 75 and you've got a number 135. That's your boundary. Any number above that, all of these numbers up here, the reason why they're all outliers is because they are higher than that cutoff. Okay? In this case, the minimum value of 10 or 15, if you did the same thing with the quartiles down here, 50% more would give you the 60. When you subtract 60 from Q1, it puts you in the negative. And there's no way in New York City that someone's going to pay you to come rent out their room. So in this case, there would not be any really low outliers. And you can kind of see that from the plot. All right. So in terms of kind of where we're at, interquartile range and box plots, being able to interpret that is a pretty important piece of the course. Hopefully that gives you a little bit more depth on what we're looking at in this module. All right, off you go.